Today I was solving number 69 in chapter 7 of the AP Chemistry Zoom Real textbook. The problem is give the maximum number of electrons in an atom that can have these quantum numbers. For part A, n is equal to 4, n is equal to 5, and also m sub l is equal to 1. Part C, n is equal to 5, m sub s is equal to 1 half. Part D, n is equal to 3, l is equal to 2. And for part E, n is equal to 2, l is equal to 1. Now, in order to solve, you must know what n, l, m sub l, and n sub s is, and if you don't, you should go back and review chapter 7.6 in your textbook, which is on page 307, and you also might want to take a look at table 7.2, which is on the following page, on page 308. That will help you with part B, C, and D and E. Part A is really self-explanatory, so I'll get started on that. For part A, n is equal to 4, and n is always a positive value. It tells you the energy level or the shell that the electron is found in. The maximum number of subshells allowed for a particular shell is equal to n squared, and also the maximum number of electrons permitted in a particular shell is equal to 2n squared. So for part A, you would insert 4 into the formula, 2n squared for n, and 4 squared is equal to 16 times 2 is equal to 32, which would be 32 electrons for part A. So that's solved. Moving on to part B, n is equal to 5, and m sub l is equal to plus 1. Since l hasn't been specified, we need to take into account all the possibles. L can either be 0, 1, 2, 3, or 4. Now, since m sub l is equal to 1, based on that, the only allowed L values are 4, 3, 2, and 1. If you reference the table on page 308, which I have here, you can see that m sub L equaling 1 can only occur when the L value is greater than 0, which is why we throw it out. Right here, you can see m sub L values of 1 are found and the L values of 1, 2, or 3. And as you can see, when L is equal to 0, m sub L does not equal 1 in any case. And it continues up. Alright, so let's bring this paper back over here. Maximum number of electrons is 8 because there are 2 electrons in each m sub L level, and there is only one m sub L level of plus 1 for each L value. So right here, 2 electrons for m sub L value, and there's only one m sub L value of plus 1 for each L value. So you're going to have 4, which would be right here. Take the actual values, you know, 1, 2, 3, 4, and you're going to do 2 electrons per value, because that's the maximum that you can have, and there's going to be 8 electrons, and n is equal to 5, and m sub L is equal to plus 1. Alright, let's turn over to the back here, and we have C right here, and for part C, n is equal to 5, m sub s is equal to 1 half. This problem is very similar to part B, except that you have m sub s this time. This value corresponds to a single electron when you have a m sub L value opposed to 2, so you have half of it. Therefore, we just need to find out how many of m sub L we have in order to know the number of max electrons. Like I said before, L is equal to 1, 2, 3, or 4. And since m sub L is not specified, we have to take into account all the L values and then add them together. So here, when L is equal to 4, you can have values, m sub L values, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. And there you have 9 values. So I'm just going to put this in parentheses so I can keep count. When L is equal to 3, you can have negative 3, negative 2, negative 1, 0, 1, 2, and 3, which there would be 7. And when L is equal to 2, you can have m sub L values of negative 2, negative 1, 0, 1, or 2, which would be 5 values. And when L is equal to 0, you can have values -1, 0, 1, which is 3 right there. And when L is equal to 0, you can have a big donut right here, which is 0, which would be 1 value. And if my math is correct, that would be 25 electrons down here. And because since ms is equal to 1/2, there's only 1 electron per m sub L level opposed to 2. So you have 1 each, and since there's 25 here, it'd be 25 electrons. Moving on to part D, n is equal to 3, L is equal to 2. Since the m sub L and m sub S values are not given, you have to take them into account. When L is equal to 2, m sub L is equal to -2, -1, 0, 1, or 2. And the number of total electrons per m sub L level is equal to 2. So you're going to have here 5 values. So you have -2, -1, 0, 1, 2. That's 5. You have 5 values, and since there's 2 electrons per m sub L value, you're going to have 10 electrons total. Alright, moving on to the last part, part E. N is equal to 2 when L is equal to 1. Now, like in part D, m sub L and m sub S aren't specified, so you have to take them into account. Now, L is going to be 1, and m sub L is going to be -1, 0, 1, and that's going to be 3 values. So you have 3 values, and then 2 electrons per m sub L level, which is here, and you're going to have a total of 6 electrons. That's going to be it for today. Thank you for listening.